So after building this Pong game last year, I really wanted a new challenge. So I decided to build this absolutely over-engineered, barely working Flappy Bird clone. So I decided to use a Arduino Nano for quick prototyping, and it has a Atmega 328P chip that is gonna come in handy later. And first I started off with a 1.3-inch I2C display, but that ended up being a regret of mine. And with that, I just started to prototype with these components and a button. Now just some movie magic, and we are ready to write the code. So for the code, I'm not gonna bore you with it. It did take me quite a long time to actually figure out how to use all the components, but after making a relatively simple prototype, I did end up realizing quite a big issue. See if you can spot it. So yeah, it's really slow, and the main culprit is the I2C display, where the I2C lines are not fast enough to draw all the sprites onto the screen, even at 15 frames per second. So instead, I ended up switching to a 7-pin SPI display, which in theory can be up to 10 times faster. And so with my new screen being selected and me wanting to make this a handheld project instead of a breadboard project, I decided to tackle making a PCB. Now, the PCB did end up having quite a bit of flaws, which you'll see that I have to fix. Fortunately, if you would like to repeat this project and make your own version, then you will find that the PCB files are fixed and there are no issues. Now, with the PCB files ready, they do need to be manufactured, and I'm not sponsored by any company, so I did again use some movie magic. But yeah, please sponsor me. The PCB is centered around the Atmega 328P IC and can be run with either 8 MHz or 16 MHz clock. A 6mm tactile SMD push button and a Type-C TP4056 module is required. On the back of the PCB, there's also a spot for a 16 MHz crystal and 3 capacitors and 2 resistors. And you're also gonna need a battery, preferably not a very big one. The TP4056 module is going to need a modification regarding the ISET resistor. If you are using a smaller battery, you would want to replace that resistor with a 10 kilo ohm one, so that the battery is going to get charged with smaller current. You can see the modified version on screen right now. If you are going to be taking the main IC off of a Arduino Nano, you can also get a 16 MHz crystal off of it. If you do that, you're not going to need an ICSP programmer to reprogram the chip. So now we can get to the assembly. Here I'm trying to get the IC onto the board along with the crystal. I'm not really gonna talk about how you're supposed to assemble it. If you want a specific video of how to assemble the PCB, then please comment down below. Here I'm just using the connector part of the female header to connect the TP4056 module to the PCB. After ordering the PCB, I realized that I should probably start making the case, as it would be really hard to make a case without 3D printing. If you want to go through these files and fine-tune them or 3D print them, you can find them in the link below under the video. I 3D printed the case in just some normal PLA at 0.1 layer height. That seemed to me to be good enough for this project. Now for the assembly, I also used some heat set insert. And here I'm soldering the 6mm push button. And yeah, that worked really well. Now with the PCB half assembled, you can check it out by plugging in a charger and seeing if the TP4056 light lights on. Now you might have been seeing some very strange abominations of some white wires and some Kapton tape. The reason for that is I absolutely forgot to add a power switch, so I needed to drill the PCB to make the holes for the switch. But yeah, no worries, as I ended up later modifying the PCB as to accommodate the push button. Now here you can find the last version of the code at the time of making this video. I'm not gonna bore you with the details. The first page has the general console mechanics and the second page has the game. If you want to download the code or get the latest version, you can find it in the link below or on my GitHub. So after soldering the display to the PCB, you can, after making sure that you put in the button, you can place the PCB into the top housing, and after making sure that the screen is not very far enough, can use a P connector to power the console and see that it works. So finally, you can just solder on the battery. And after making sure that the charger works, and you can see the red light in the bottom, you can just flip on the power switch, and yeah, that's the finished build. Again, as I've said before, all the links to the 3D printed files, to the code, can be found down in my GitHub. Thank you very much for watching my video. Now this is my first video that I've ever made. If you want to leave a suggestion, please leave it down in the comments, and I'll be sure to respond to you if you have any questions. Thank you.